will talk about multi-cloud logging for incident detection and investigations. So I'll start with a quick intro about myself. So I've been doing security for over 10 years. I've been both on the blue teams, the builders, and red teams, the breakers. I use cloud a lot, and I use a lot of different clouds. My main ones today are AWS, GCP, and Azure. We'll talk a bit more about those. And currently I live in Seattle, which, as some of you may know, may be considered the center, the epicenter of the cloud industry. So we have Amazon right here, we have Google Cloud, and we have Azure on the east side. My contact information is here. Please feel free to reach out for anything, any questions, any follow-ups. All right, so I'm a member of the cloud security team at Uber. So we use a lot of cloud at Uber, and we'll talk a bit more about that. But I just wanted to show our mission. Essentially, we want to enable Uber users and services to leverage the cloud with confidence for their business needs in the most secure, productive, and efficient way. So let's start about talking about the logs. So this is just a phrase I came up with. And I'll explain a bit about why that is, right? Logs are best known for not knowing them. So in so many security incidents, in so many investigations, probably one of the first things that is done is, hey, let me see your logs. Let's see what happened, right? And then the race starts, right? So where do I find these logs? Is it actually logged? Are all the actions actually being logged there? How do I make sure that everything, what I see, is everything that happened? And in many cases, I think way too many cases, people just don't necessarily know where to find the logs, which is quite sad. So we'll talk a bit about some best practices in this regard. A bit about the agenda for our talk. So I'm assuming that this is a mixed talk, mixed audience. So we'll really start with the intro about talking about logs 101. Then we're going to talk about more deeply about what the challenges are once we go up the scale. And then our proposal to deal with this challenge is what we call redundant centralization. Next, we're going to talk a bit about some of the security aspects, detections and investigations, security aspects of the logging. And then quick war story or quick kind of real life scenario that demonstrates how we use detection and investigation with logs. We'll go through a quick attack mitigation flow. And finally, we go to some topics on managed services. Again, services that do some detection and investigation for us and are presented and managed by the cloud providers. So we're going to talk about how they correlate with the logging and detection that we do on our end. All right, so let's start talking about the logs. What are logs, right? So this is just a definition I pulled out from Wikipedia, right? A log file is a file that records either events that occur or messages between different users of a communication software. So essentially, someone did something, right? And then this has to be logged. This has to be kept. Something that they did and who did that needs to be logged, needs to be written down somewhere. Now, logging is a necessity for several things. First, for software development in general, right? We use logs to diagnose issues. We use them to make sure that our tools, our software are stable. We use them to optimize our software, etc. They're also used for legal purposes. So for example, for audits, right? Whenever you have an audit, people might want to take a look at your logs and make sure that everything that's been done has been written down somewhere. Retention and non-repudiation, right? So these terms essentially that mean that once we have the logs, we cannot repudiate. We cannot say that we did not do something. So that's one of the legal requirements. Statistics as well, right? So how many actions of specific type were performed? right? Can we optimize based on that, etc. And finally, for security, and this is something that probably will be one of the main topics here. So detection, right? Once we have the logs, if we look at the logs often enough in real time, we are able to detect certain things that are security related, right? We can also use logs for investigation, right? When something bad happens or something suspicious happens, we need to take a look at the logs to get us more information. And then for hardening, so what do I mean by hardening? So essentially, if I see, just a quick example, if I see access that was not intended, right? So that must mean that I've missed something in my security baseline, right? So I need to prevent that from happening again, from occurring again. And so I harden my system based on what I see in the logs. Okay, so just a quick view, right? Again, to make sure that we all understand what's being done. And this is an example of the clouds. We're going to talk about clouds a lot. Let's say Alice performs an action on the cloud. This action is executed on the cloud, but the action is also logged, right? So everything that's being done by Alice, everything that's being performed on the cloud, all that is being logged, is being stored securely in some readable format. So this is an example of a log that shows creation of a S3 bucket in AWS. Right, I'm not going to go through all the details, but essentially we are able to see who created the bucket, where the bucket was created, what time that occurred, etc. So a lot of details that are not shown here, right? All of these we can see and we can analyze afterwards. Another example, in GCP, let's say we start a virtual machine in GCP, right? So this, again, this is a log that I took from GCP logging, what used to be called Stackdriver, right? So we see the ID, we see the insert name, essentially what kind of logs this is coming from, what the operation is, if I expand that, essentially the time and what happened, right? And in this case, they also provide a severity, which is just a notice, hey, somebody started a VM. All right, now this is all nice and fun, but let's take a look at what happens when we scale. So let's say our organization, hopefully it grows, right? So we have more users, we have more software, we have more resources. The more we grow, the larger the organization grows, the more logs we have to collect, right? Because again, our intent, our purpose is to collect all the logs from all the actions that are being performed on all the resources, all the clouds, pretty much everywhere. So the more we grow, the more logs we have to collect. We have to store them, so we need to have more storage capacities. We have to process and analyze them, right? So again, more compute capacity for doing the analyze. Now, scale is, like we can understand, it is a challenge, right? So some of the questions we may ask are, hey, where are my logs? Oh, we just went into this new cloud provider. Do we log everything that's happened there, right? How do I get to these logs, right? And how do I get to them timely, quickly, in real time, right? I want to make sure that I'm looking at real-time events or recent events. So I need to be able to get to the logs quickly. Are we collecting the logs from everywhere? Again, all the possible resources, being on-prem, on the cloud, all different clouds, etc. Are we detecting everything, right? So do we have detection rules applied to the logs? And we'll talk about it in depth. How to query logs from platform X or on platform X, right? So some of you may be familiar. So for example, AWS has their own tools to query logs, right? For example, something that's called Athena. GCP provides querying with the logs if we export the logs to BigQuery, etc. So how do we query these logs? And now, once we have all these different ways to query the logs, how many people do we need to actually employ with everyone knows their own expertise to query logs in a particular cloud? Or maybe can we do that centrally, right? So the answer is yes, we can, and I'm going to talk about it in a minute. Okay, so again, going back to our presentation. So Alice performed an action on the cloud, action is executed, we want action to be logged. Now, once we add more clouds or more inputs or inputs to the logging, right, all these actions need to be logged as well. And we need to be able to observe these actions. Now take notice here, what I wanted to show is that we log these actions on the cloud itself. So we store logs on each cloud on its own, but we also export logs to some central place. So next we're going to talk about why we do that. Going back to Uber a bit, right? So a bit about kind of our approach to using the clouds, right? So we have what we call a multi-cloud environment. That means use your own cloud, bring your cloud out of, right now it's 5 clouds that we support, but for the most part, mainly we support the 3 large ones, which is AWS, Google Cloud, and Azure. But we have occurrences where people prefer to use other clouds, and so we allow that. Now, why do we do that? So just quickly about the reasoning for that. So what I see happens in many organizations, right, that limit the usage of, say, just use on-prem services and tools, or just use this particular cloud. What I see happens is that there's an engineer that comes and says, oh, I can actually do that better on a different cloud, using a different cloud provider, right? I know how to do that, I can do it quickly. There's some benefits from doing that. So they open the account on this different cloud provider, which is not supported by officially by the company, and that will happen. So now this essentially becomes what we call a rogue account, unknown account, or shadow IT to the security team. So the security team doesn't know that we even have, the company even has resources in that new cloud. And that's a problem, right? We need to have visibility, 100% of visibility. So that's why our approach at Uber is, hey, these are the clouds, just pick your own, your favorite cloud, deploy your software there. And so we operate at large scale. We have several organizations that Uber consists of. You might have heard of some. We have, just as an example, we have hundreds of AWS accounts and thousands of GCP projects, and as I mentioned, some more exotic clouds as well. All right, so let's discuss the proposal, right? This is our way to deal with the challenge of scale and logging at scale. So we call it redundant centralization. Now, we store the logs at the source, as I mentioned in that previous picture. So we need to store the logs on each source, being, say, AWS or GCP or Azure, store them securely for the purpose of redundancy, right? So even if we do export the logs elsewhere afterwards, we still want to be redundant. We still need to make sure that we have the source stored on that particular place where it happened. Another reason for us doing that is maintaining chain of custody, right? So if we do export logs elsewhere, that may have issues with maintaining chain of custody. How do we prove that we didn't mess up with the logs if we export them elsewhere? So that's why we still need to store the logs at the stores as well. And then native tools usage. So many cloud providers provide tools that observe, monitor the logs on their own. As I mentioned, for example, Athena does that, right? So we can create rules in Athena with Athena queries to look at the logs. And then we possibly may want to take advantage of these native tools. So we need to store the logs at the stores. But we also propagate logs to on-prem data centers, and this is our kind of centralization. So we collect the logs from all the different sources, from all the different clouds. I'm going to talk in a second how we do that. And we do that to perform centralized detection, analysis, and we also want to be able to query logs centrally. So this is an example of how we do that with GCP. So feel free to take snapshots. So just quickly, an example here. So starting from the right, kind of upper right side, right? So we have GCP folders, GCP projects, and then in the center here we have kind of a zoomed in view of a GCP folder project. So let's say we have IAM actions, we have compute engine actions, we have storage, right? Somebody accesses, writes, or reads from the storage. This all is being forwarded to GCP native logging. And then this is being done. So in GCP, it's called a sync, right? So these syncs are being propagated from all the GCP projects and folders on an organizational scale. And this is being forwarded into what used to be called Stackdriver. Now it's just called logging, aggregated logging. Now, this is where we collect the logs from all the different projects and folders in GCP. Next, as I mentioned, we want to do two things. One, we want to store them natively on GCP Cloud Storage. And we also want to forward them to our centralized storage, right, for detection. So we do that with GCP's PubSub. So through PubSub, we forward the logs to what we call Detection Platform Service. And we'll talk a bit more about what it has. All right, this is an example of pretty much the same thing, but in AWS. Again, AWS accounts, we have quite a few of them. If we zoom in into each of these accounts, so any actions that are performed on EC2, right, starting, stopping instance, actions that are performed on IAM, adding new users, for example. S3 is another example, right? So we collect these logs. AWS has a service called CloudTrail, which essentially collects audit logs. And then we forward them to, again, aggregation mechanism that stores the logs natively on S3. And also, remember, we also want to propagate the logs to our centralized storage. So the way to do that here is slightly different. So we use an Amazon service called Amazon Simple Query Service, SQS, which essentially notifies us that new logs have arrived, right? So in conjunction with S3 events, CloudWatch events. So once we have new logs, we notify Detection Platform Service, which is where we store the logs. Then we go and pick up the logs. We get the logs from AWS. So if you see the difference here with GCP is that GCP has a push sort of form, and here we have a pull form of logs. Okay, now quickly a few words about what is this detection platform where we output the logs to. So essentially, we need a centralized place to store the logs and to query the logs. And the way we do that is with Hadoop storage, right? Secure Hadoop storage or secure HDFS. This is where we propagate the logs to, and we are able to query the storage. So we'll talk about it in a second, but essentially we can say, hey, show me all the logs with an event that has a certain IP address in them. So this is our kind of detection platform. This is what it does. All right. So let's keep talking about the security aspects of the logs that we store, detections and investigations. So our detection platform is currently rule-based. What it means is that we have to manually come and say, okay, what kind of events we need to look for. So, for example, adding a new IAM user, right? This may be a potentially sensitive event. We may want to take a closer look and maybe to alert on that. So I'm going through the rule examples here. AWS CloudTrail is turned off, right? This is a suspicious event, right? CloudTrail is the login service for AWS. Why has someone turned it off? So this potentially may be an indicator of compromise. AWS SNS or SQS is turned off, right? So SNS and SQS are often used to page of potentially sensitive or suspicious events. An attacker can turn them off so that they can pretty much cover their tracks. Example for GCP, an organizational level member is added to the IAM, right? We usually don't add members to the organizational level. We usually add IAM members to project levels in GCP. So adding organizational level member is essentially giving kind of very wide permissions. So this is a suspicious event potentially. Now, in future, we want to, and we're already working on developing an AI-based approach right? So essentially build a model that can distinguish between potentially sensitive, potentially suspicious events and everything else. We have this rule-based engine use Kafka topics. So we have several mechanisms ascribed to these Kafka topics. So whenever something happens, whenever a rule is triggered, we are getting notified, right? And then that notification can go through maybe from Slack to maybe PagerDuty or some sort of mechanism that alerts the on-call folks, and can also be propagated to other mechanisms that can provide automatic remediation. So we'll talk about it in a second. And we use Query Builder, right? Query Builder, it's an open source tool. It's kind of a unified search engine that allows us to look into HDFS and query HDFS logs. So we use that for, remember I started a presentation saying about, okay, something happened, I need to now query all the logs. So because we have all the logs centralized, we can now query all the logs for a specific event. All right, so a quick, so some call it a war story, right? I'd rather just call it, right, a real-life example of an attack mitigation flow. So this is like I said, a real scenario that happened, a real story that happened. A set of IP addresses for malicious service was published. So as you know, there's quite a few databases from where you can pull malicious IP addresses, right? And these can be possibly command and control servers, or just some potentially malicious denial of service bots, etc. So we pulled a new set of IP addresses of these malicious services, and then what we wanted to see is, hey, have we ever talked to one of these services, rather servers? So we did a log query. And because we're centralized, all the logs are centralized, we can quickly perform this log query, and we can see whether one of these IP addresses has been logged anywhere on our system. And we did actually find a single cloud VM to have communicated with one of the servers. So these are thrown manually, right? And I'll talk a bit about possible improvements, but we saw that, okay, this is one cloud VM that we found, and it communicated with one of these potentially malicious servers. So next comes the remediation, right? So what we do is we segregate the VM, we take a snapshot of the VM, we perform investigation of the snapshot. Luckily, in our case, we determined that the IP address in this, that one IP address in the set of the IP addresses that we got, it was actually false positive, meaning it was actually not a malicious servers that we communicated with. So what we did next is essentially, okay, let's take the remaining IP addresses, right, that are deemed to be malicious, and let's add them to the detection rules that we talked about previously, right? So now whenever a login entry is observed with one of these IP addresses, we will be alerted. We, being the security team, we will be alerted. So what could have been done better, right? Kind of the learning outcome, right? So of course, we don't want to do it manually, right? We want to automate everything. We want to import all new IP address sets for potentially malicious servers. We want to import them automatically and timely, right? So once they appear on publishers that we trust, let's import them automatically to our detection rules. Let's add these new IP addresses. Next, we want to do remediation automatically, right? So we don't want to have engineer starting manually to segregate a potentially VM, compromised VM instance, right? We want to segregate it automatically. Maybe, right? So that there's a question mark. Segregate VMs, maybe. Why maybe? What if it's a production sensitive workload that's running on it, right? So in that case, we need to figure out which VMs are sensitive, are related to production, and then we can't segregate them automatically, or can't stop them, terminate them automatically. We want to first talk to the owners. But on the other hand, if it's not sensitive, if it's not production, right, maybe we can just stop them automatically. Okay, we want to also automatically take snapshots and provide these snapshots to the investigation team, and we want to alert owners of these potentially compromised resources and alert the security teams automatically with the finding. So again, our approach, as often preached by so many folks, is automate everything, right? We want to remove the human from the process. So the rules are being added automatically, the detection is being done automatically, and alerts are being sent automatically, and the remediation takes place automatically if possible, as we discussed. All right, so finally, let's talk a bit about managed services. So that's something we need to consider. So what are these managed services? Well, most cloud providers have their own detection services. For example, for Amazon, right, there's guard duty, there's the guard duty, that's a service that essentially detects potentially malicious activities, something like maybe a denial of service attack. In GCP, there's a service called Event Threat Detection. In Azure, there's a service called Advanced Threat Protection. So these folks or these services, they detect potentially malicious activity and they are able to alert us. So essentially, they're kind of doing a lot of what we discussed already on their own, right? Amazon Detective is a service that was released about a year ago in the last re:Invent. And that allows us to actually dive deeper into what happened. So they do the logging and querying the logs, and they store the relevant information from the logs for us, and they actually don't charge for storing these logs. So pretty cool service. But these services are, there's a lot of overlap between those services and what we just discussed. So how do we kind of correlate between them? Well, it's important to note that a lot of these services, the managed services, they're paid. So maybe we would prefer to pay for them and just let them do the detection for us. On the other hand, we still have to do logging, right, for legal purposes, because we need to preserve logs in order to be able to withstand potential audits, right, which happens. So we still need to do logging on the one hand, so we still have to pay for these logs. Or we can additionally potentially pay for these managed services. So which ones do you choose? Well, usually most organizations that I see, they do logging on their own. They use some of the managed services that clouds provide, and they use some sort of a hybrid approach, right? So they have their own detection, and they also rely on some of the managed services detection. How do we correlate? So that's a challenge. How do we correlate multi-cloud detections? So essentially, when we have so many clouds that we use, right? So maybe the 2 or 3 of the largest cloud providers, and maybe some more exotic clouds. All these have their own detections through their own managed services. But how do we correlate? For example, if our organization is being attacked, maybe from the inside, maybe from the outside, and again, going back to the example of a single IP, how do we correlate detection or an alert that happened on cloud A with cloud B? How do we make sure that an alert that we observed on cloud A hasn't occurred, or maybe has occurred on cloud B, right? So that's an important challenge that can be solved with centralizing the logs from all the clouds. So what we do is, as we mentioned, we use centralized logs, but we also need the logs to be uniform enough so that we can query them. We prefer SQL queries, so we need to do some massaging of the logs so that we can then do SQL queries on them. And then we also want to have single rule-based detection. So for example, IP denial list that will apply to all the different clouds, right? But with a single rule, essentially, so that we don't have to rewrite the rule for every different cloud. So that's why we need to make sure that the logs are uniform. And we do that, like as I mentioned, with slightly massaging the logs that we get from the clouds. This is what allows us to support kind of uniform SQL queries. All right, so this is the end of my talk. I'll be happy to answer any questions, either now or please feel free to reach out to me afterwards through email or LinkedIn. Thank you for having me. Thank you for listening, and have a good, safe rest of your day.
Thank you very much. Thank you for that great talk, Michael. Michael, are you with us? Will you join us in the Zoom?
Yeah, right here.
Hey, how are you? Welcome to the conference. The people who run the logs or handle the kind of the auditing of the logs normally see all the horror stories. Without giving away too much, um, what 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 kind of situations? Let's see if I can phrase this correctly. What kind of situations would you like to see someone avoid?
Right, and probably first and foremost, I would want to avoid the security personnel not knowing where to find the logs, right?
Sure.
And that needs to be done so quickly because once there's an incident, you need to be able to provide as much information to enrich information that's already available very quickly. So all the logs from pretty much all the available platforms need to be ready, right? Need to be at a standby, and ideally you would just need, to run a simple SQL query and get the data that you need.
Mm-hmm. And I mean, are there any tools that you guys would use to aggregate that kind of thing and give you perhaps some insights rather than trying to find the needle in the haystack?
Yeah, absolutely. So one thing that I actually didn't mention in the talk is that we're actually using Logstash, an open source tool to aggregate and do the massaging, right, to uniform the logs, the different forms of logs that we're getting. So Logstash, the trick about it is that once we have a lot of input, we need to deploy Logstash on enough infrastructure, on large enough machines. To be able to withstand that pressure from coming from all the different clouds.
Yeah, I suppose that kind of would massage the logs, as you say, or present them in ways which would give you the insights in a picture tells 1,000 words type of situation, right? Rather than finding boring lines trying to navigate your way through rows and rows and rows of lines that pretty much are meaningless if you look at them just as they are.
Oh, absolutely. Yeah. When we optimize during the massaging, we actually remove a ton of data that we just find not relevant for the sake of security. But we do still, as I mentioned during the talk, we do still store everything as originally was logged on the actual originator platform.
Okay. Right. I have a question around COVID, and tell me about your work mode now that you guys are also under the various lockdowns that have been happening. Are you mainly working remotely? Where are you located currently?
Yeah, thanks for asking. So actually behind me is the Amazon offices in Seattle.
Okay.
As you might have heard, a lot of large and small tech companies, they are now in a work from home mode. So
Yeah.
we've been doing that for I think since March or so, and we're expected to continue to do that for at least the next several months. It's been an interesting experience to kind of get used to this new work mode. But I think right now we're just all very much used to, just a lot of Zoom meetings during the day and very little personal contact. So there's
Michael,
some
I wonder if I can throw a question to you about the business per se. I mean, you might have some idea. How has the lockdown or COVID affected the bottom line business?
Yeah, so it's funny that you ask actually. So actually today we released the quarterly results. So you're all welcome to take a look. I think in general, I'm not sure if I can speak about the finances. I'm not qualified to speak about finance. But as a writer, as an eater, I often see a lot of very interesting innovations coming from actually the users and the drivers on the platform. So a lot of them, they're installing, this plastic segregation separation either in the cars. We obviously enforce, wearing masks, etc. I do hear and see quite a lot of my friends still use a lot of these services.
Yeah.
Safely enough.
Well, that's cool. That's cool. I have a question from one of our audience. So thank you for the talk. He or she, do you collect only application logs or any kind of logs, OS, instances, start or stop logs, etc.?
Thank you for that question. That's a great one actually, because obviously there's pros and cons to that. Right? If you collect everything, it's a lot of storage. It's a lot of space that we need to pay for. So the answer is we selectively pick the information that we need to collect and store. So in sensitive projects that deal with sensitive data, for example, financial data, we store everything. In other projects, we pretty much ask the owner and say, hey, so we stored these by default? So for example, the audit, right, the actions, we store these by default always, but do you think you will need additional services to be stored and logged as well? And then if they pick to, if they choose to, then we do that.
So I guess you guys are offering them up a menu of abilities, if you like, given the wealth of data you have in the logs, and then they may base a business decision on that.
Exactly. Yes.
Fantastic. I have another question from our audience. How easy is it to have a self-healing of system based on logs?
Yeah, I think I discovered, to some surprise, that it's actually pretty easy. It's not that difficult, right? So if we talk about, take GCP, for example, right? There's something that's called a cloud function, which is kind of like a Lambda function of AWS that can do manipulation on your behalf. So you can trigger this cloud function or Lambda function with an event that happens that is picked from the logs. For example, something that looks malicious, like as I mentioned, like a malicious IP, right, or a malicious IAM user that shouldn't have been given certain permissions. So this event will trigger cloud function through maybe PubSub in GCP's use case. And the cloud function will execute the remediation by, in our example, removing, taking back the permissions, right, or blocking, creating a firewall to block that IP. So it's not only it's quite easy to just write it on your own. There's actually already quite a lot of open source available code for this cloud function that will do remediation for you. In GCP's example, you can take a look at Forseti. It's I think it's a largely open source available platform where you can create your own remediation.
Thank you, Michael. Fantastic. I think that's all the time we have for questions. I want to thank you so much for giving us your insights. I heard quite a lot of interesting things around incidents and around the logging, but also, the extra little bit around, logs are a mine of information that could also augment the business and not only the security or the functionality of the applications. So thank you very much. Have a great rest of day. I'm sure you might have a few more questions, people contacting you through the Eventora platform, and we hope to see you in Greece at some point. Have you been to Greece?
Not yet. I really want to. Hopefully the next year once.
Fantastic. Hopefully at the next Open here in Athens, we can welcome you and see you in the flesh. So thank you so much. Have a great rest of the day.
Thank you, folks. Thanks a lot.
Awesome. Fantastic.